Okay, so we have this rather interesting exam question on vectors. November 2018 Excel, November 2018 paper 1, so non-calc. Question 21. My pen marking. Yeah, so okay, 5-mark question. Interesting. So it says we're given a triangle AB. Okay, OPM and O or APM, sorry, straight lines. M is the midpoint of AB. Okay, O to A is little a, O to B is little b. I'll give you the ratio OP to PM, 3 to 2. They want the ratio of ON to MB. Okay, now, so straight away, what I'm going to do to answer this question, we're going to consider similar triangles. Okay, so what we're going to do, we're going to draw a parallel line like there. I'm going to call that point there. I'm just going to call it the point X. Okay, so that's parallel to the line AN. Okay, so what that means basically is that we've got similar triangles. Now, what I'm going to do first, I'm going to just call this vector. Because I know O to B is a little bit. I'm going to call that KB. It's obviously some multiple of B. I'm going to probably try and find K. Obviously, K is between 1 and 0. There's a fraction of the vector B, isn't it? Which makes it a bit neater. Okay. So K is between 0 and 1. It's fine. Yeah, and because M is the midpoint, the triangles we're looking at, okay, we're looking at this triangle here, okay? So if I enlarge that triangle using M being the midpoint, clearly I get this triangle, okay, the big triangle with a scale factor, which made that bit neater. The scale factor obviously being 2 to 1. So the big triangle, the green triangle, is twice as big as the other triangle. We know that because M is the midpoint of the line AB. That's the important part, it's the key to the whole question, okay? So I've said that O to X. So I've said to O to X is K lot to B, multiple of B. Okay, well, what does that mean? That means basically that this vector, so the vector X to B, okay, must be 1 minus K lot of B. I know that because if you add them together, KB's will cancel, you're left with B. Okay, so that's the important thing to say there. Now, what I'm trying to do really in this question, I want to know the vector AN. If I can find the vector AN, that's the key to the question. Okay, now, I know A to N is twice the vector M to X. So M to X is the key to the question. Now, I know that M to X is M to B, M to B, you put your line, your arrow, plus B to X. Okay? Yeah, makes sense. Now, what is M to B? Now, M to B is obviously a half A to B. So that's a half vector A to B plus a vector B to X, obviously. Again, as neat as possible. Okay? Well, the vector A to B, okay, from A to B, we're going to go A to O plus O to B is going to be B minus A. The vector B to X is obviously the negative of the vector X to B. Okay, remember the vector X to B was 1 minus K lots of B. So negative of that would surely be K minus 1. Yeah, lot of B. Okay. Makes sense? Okay, so that's the vector M to X. If I just work this out, okay, what have I got? What have I got? I've got half B plus KB minus B minus a half A. So altogether I've got minus half A. Yeah. Half B minus B is minus half B. So I've got plus K minus a half lot to the vector B. Now we know that A to N is twice that. So that tells me the vector A to N, which is the key to the question, is twice that. So it's going to be minus A plus 2 lots of k minus half is 2k minus 1 lots of b. Okay, good. Now, I'm interested in on, the vector O to n. Now, O to n is clearly, I want to go O to A plus A to n. Now, remember, when you do this question, you know that O to, it's a bit neat, sorry guys. You know the vector O to n has to be some multiple of the vector O to b, which is little b, isn't it? So it's got to be a multiple of b. Has to be a multiple of b. And clearly it is, because what happens is that O to A, which is little a, would cancel out the minus a. So you can get little a minus a, which is what you expect, plus 2k minus 1b. So you knew it had to be a multiple of b, or it wouldn't have made sense. Okay? And parallel vectors, guys, are a multiple of each other. Okay? So I now know the vector O to n is 2k minus 1 lots of the vector b. Okay, right, this is where now we're going to consider two different triangles, okay, two other similar triangles. Just by putting that line in, that vector m to x, okay, I've created similar triangles effectively. So what I'm looking at now, what I'm considering now, I'm looking at, excuse me, so this triangle here, okay, and then this triangle is clearly an enlargement of the yellow triangle. Do want it to be as neat as possible. I apologise. So this triangle is an enlargement of the yellow triangle, clearly. Okay. Now, what is the enlargement? Well, we was told earlier in the question, O to P, P to M is 3 to 2. What does that mean? That means that O to M is effectively 5/3 of the vector O to P. Yeah, because 5/3 of 3 is 5, isn't it? Obviously, makes sense, yeah? So what does that tell me? That tells me that my vector O to X, which we've called KB, has to be 5/3 of the vector O to M, which I've just found. So it has to be 5/3 of my 2k minus 1b. Yeah? So that's the way it works. This will allow me to find k, essentially. Because what have I got here? Well, what have I got here? Let's just make it a bit neater. I've got KB. I've got 10/3 KB. Yeah. Minus 5/3 of B. Cancel the B's. Solve for K. So let's bring this over here. Let's bring that over there. So 5/3 is 10/3 minus 3/3 is 7/3 K. Cancel the 3's. Divide by the 7. K is 5/7. Well, if K is 5/7, let's go back here. Yeah. We now know the vector O to N. When we're trying to find the ratio O N and B, is, well, 2 lots of 5/7 is 10/7 minus 7/7 is 3/7 of B. So O to N is 3/7 of B. If O to N, this is 3/7 B, yeah, the remaining bit, N to B, must be 4/7 B. Well, clearly that's just in the ratio 3 to 4. So I think my answer, or the answer, should be 3 to 4. As firmly as possible. 3 to 4. That's the final answer, should be. Just check that. Yeah, perfect. Thank you.